Hi class, so today we're going to review chapter 2 using ratios, percentage, and proportions. Our topics for this video will be numerical ratios. Our learning objectives are to describe the use of ratios and proportions in the pharmacy, compute pharmacy calculations by using ratios and proportions. So numerical ratios. So what is a ratio? A ratio is a numerical representation of the relationship between two parts of a whole or of the relationship of one part to the whole. So you can think of this as what we reviewed in chapter 1 of fraction. Okay, so it's one of 8 pieces. But a ratio, you use a colon instead of a line between the two numbers. So ratios may be written with a colon between the numbers, read as per, of, to, or in. The ratio 1:2 could mean that the second part has twice the value of the first part, or that one part is something within a total of the two parts. Okay, so in pharmacy, we like to use ratios as fractions. So that's very important that you understand how to add, divide, multiply fractions, subtract fractions as what we learned in chapter 1. But today, in this instance, we're going to review them as ratios. Okay, so 1:2 can be read as 1 part to 2 parts, or it may also be written as a fraction, which is 1/2. 3:4 is read as 3 parts to 4 parts and may also be written as 3 divided by 4 or 3/4 or 3/4. Okay. So again, you gotta pay attention to each unit. So the 1 part to 2 parts or 1 part of 2 parts. Okay, so see that the units in this instance is parts. In pharmacy, we're going to use weight or volume. So this could be 1 milligram to 2 mLs, or 1 microgram to 2 mLs, or 1 milligram to 2 tablets. Okay, so think of it that way. And it can be vice versa. So it could be 2 milligrams to 1 tablet or things like that. Okay. A ratio are commonly used to express concentrations of medication in a solution. So for example, a 1:100 concentration of a medication means that it is 1 part of the medication in 100 parts of the solution. So 1 gram, which the grams would be the unit, per 100 mLs. An ml is a unit of measure. The ratio may be manipulated by multiplying or dividing both parts of the ratio by the same factor. Okay, so the same thing. If we want to increase the medication, we would multiply. If we want to decrease the medication, we would divide both numbers. So some medication labels have more than one ratio listed. For example, the aminophylline label shown below includes 3 ratios, each descriptive of the medication's concentration. So as we see in this label, there are 3 different ratios. We have the 500 milligrams to 2 mLs. We have the 25 milligrams to 1 ml. And our last concentration would be the 19.7 milligrams to 1 ml. So this helps the pharmacy technicians or pharmacists use the best option whenever they're calculating, for a dosage value. So if a medication is written in volume, the pharmacy would focus on the mLs portion of the 3 different ratios. While if a physician orders milligrams, then the pharmacy would focus to try to use the amount. So if for example, the physician orders 1,000 milligram of the drug, they know that to multiply the 500 by 2, that means that they would multiply the mLs 20 by 2. So the medication that the pharmacist will or technician would withdraw from the vials would be, they would use 2 vials because each vial contains 20 milligrams. 20 mLs. So the dosage is 40 mLs, so they would pull 2 ampules and withdraw that volume from both ampules and insert it into either a bag or directly to the patient, depending on how the prescription is written. So it's very important to figure out which which dosage form you're going to use, or which ratio you're going to use in order to calculate the volume or the amount of medication that the physician is prescribing. The medication label indicates the ratio of the active ingredient, and the ratio may be manipulated by multiplying or dividing both the parts of the ratio by the same factor. So like I said earlier, if we wanted 1,000 milligrams, we would multiply both ratios by the same factor, which in this case would be 2. If the dose needs to be decreased, you multiply it by the factor by the you multiply the ratio by the factor. If the dose needs to be decreased, you divide the ratio by the factor. So this is our example, levothyroxine. So the physician has ordered that a patient take half of a 137 microgram tablet of levothyroxine. How many micrograms will the patient take? Okay, so it's asking us for micrograms. Now we're going to look into our medication information. So the patient's going to take half of 137 micrograms. So we would need to pay attention to this medication and the amount that we're taking. So in this case, we're only taking half of that tablet, so we would technically divide 137 micrograms times 1/2 is equal to 68.5 micrograms. Division method, we would 137 micrograms divided by 2 equals 68.5 micrograms. Or a different way to write it down is 137 micrograms over 2 will give us 68.5 micrograms. Using dimensional analysis described in chapter 1, 137 micrograms over 1 tablet, because again we know that each tablet, according to our label, each tablet contains 137 micrograms or 0.137 milligrams. Okay, so that's why we have 137 micrograms over 1 tablet. Times, we want to get rid of tablets, so tablets will go on the top. And in this scenario, they went ahead and did use a decimal instead of the half. So it converted the half to a decimal, which is 0.5 tablets per 1 dose. So tablets cancel, and you multiply 137 times 0.5, which gives us 68.5 micrograms. A common dosage form is a solution, a liquid mixture in which the minor component, the solute, is uniformly distributed within the major component, the solvent. A similar dosage form is a suspension. So a suspension is a mixture in which the solute particles are mixed with but not dissolved in the fluid. So as you always, if you always think of a suspension, usually antibiotics, so think of it if you have children, you are given, sometimes a pharmacy will mix it for you, other times the pharmacy will give you the directions how to mix the suspensions. So the suspensions have small particles, they're granules, it's not mixed yet. So you would add the mixture, which most likely would be water. And every time that you dispense the amount of medication to your children, the instructions are say to shake the bottle before you administer the medication. So it's because that the reason why suspensions, the particles don't dissolve completely. So that's the reason you always have to mix it, or means you always have to shake it before you give the medication. Okay. So example, I'm sorry, like a quiz or quiz question. Express the ratio as a fraction and reduce to the lowest term. So we have 1 to 7, and that's our ratio. How would we write this as a fraction? So again, we would leave the 3 as the numerical value, and then the colon would signify the dash line, and then the 7 would be in the denominator. So the answer would be 3 over 7, or 3/7. Okay, so this concludes the first section of this chapter. So I'll see you in the next video. And okay, that's about it.